If you take a completely straight plastic straw and drop it into a glass of tap water, your eyes immediately tell you a lie. Right at the waterline, the straw seems to snap. The submerged half shifts to the side, looks noticeably thicker, and no longer lines up with the top half. If you pull the straw back out, it is perfectly intact. Put it back in, and the break reappears. It is one of the most familiar optical illusions in daily life, but the mechanics behind it explain everything from how cameras focus to why spears miss fish when you aim straight at them. To understand why the straw appears broken, we first have to discard a common misconception about light. We are often taught that light travels at a constant speed of roughly 300,000 kilometers per second. While that is true in the vacuum of space, light slows down whenever it travels through matter. Air is relatively sparse, so light zips through it almost at full speed. Water, however, is much denser. The packed water molecules interact with the electromagnetic wave, slowing light down to about 3/4 of its vacuum speed. This change in speed is the root cause of refraction, but slowing down alone does not bend a beam of light. If a light ray hits the surface of water straight on, at a perpendicular angle, it simply slows down and continues in the exact same direction. The bending only occurs when light hits the boundary between two materials at an angle. Picture a heavy lawnmower being pushed from a smooth concrete driveway onto a patch of thick grass. If you push the lawnmower straight ahead, both front wheels hit the grass at the exact same moment. The mower slows down, but it keeps moving in a straight line. Now imagine pushing that mower into the grass at an angle. The right wheel crosses into the thick grass first and immediately slows down. The left wheel is still on the smooth concrete, moving at full speed. Because one side is moving faster than the other for a brief moment, the entire mower pivots. Its trajectory shifts toward the side that slowed down first. Light waves behave in the exact same way. When a wavefront of light traveling through water approaches the air boundary at an angle, one edge of the wave exits into the air first. The instant it hits the air, it speeds up. The rest of the wave is still bogged down in the water. That differential in speed across the wave causes the entire light ray to bend. When moving from a dense medium like water into a less dense medium like air, light always bends away from the perpendicular angle of the surface. Now, here is where the human mind completes the trick. We see objects because light rays bounce off them and enter our eyes. When you look at the underwater portion of the straw, light bounces off the plastic, travels through the water, bends as it exits into the air, and finally strikes your retina. But your brain does not know that the light bent along its journey. The human visual processing system operates on a hard-coded assumption. Light always travels in perfectly straight lines. When light enters your eye at a new bent angle, your brain unconsciously traces those light rays straight backward in a direct line. Because of that backward projection, the brain constructs a visual image of the underwater straw at a point higher and slightly to the side of where the straw actually sits. You're not seeing the real physical straw under the water. You are looking at a virtual image created by bent light rays. This is also why the submerged part of the straw appears slightly magnified. The curved surface of a cylindrical glass acts as a weak lens, spreading the outgoing light rays even further apart and stretching the virtual image your brain constructs. This effect is not just a parlor trick in a drinking glass. Archery fishermen learned centuries ago that if you aim your spear directly at a fish in the river, you will miss every single time. Because of refraction, the fish appears closer to the surface than it really is. To hit the target, you have to aim significantly below where your eyes tell you the fish is located. The simple bent straw in a glass of water is a quiet reminder that our sense of sight is an interpretation, not a direct window. Your eyes receive light that has been slowed, pivoted, and bent by the laws of physics, and your brain does its best to map that light back into a straight-line world. The straw was never broken at all. Light just took the scenic route on its way to your eye.